Hey guys, today I will be showing you how to make an obstacle avoidance robot. The parts you need are 2 Parallax continuous servo motors, 1 high-tech HS 422 standard servo, a Tamiya track chassis kit, an Arduino microcontroller, a battery pack with a barrel connector, mini breadboard, Parallax ping sensor, jumper wire connectors, and jumper wires. And you will need pliers or scissors and hands. Okay, so the first step is to complete your kit, except you do not need to complete the battery pack or motor. You can just toss it or just use it for another product, whatever, I don't care. But all you need to complete is the 3 pairs of small wheels and 1 pair of big wheels. And you will need these 2 teeth wheels. So first, you're going to use your pliers and just chop off the part, this part sticking out, and just make sure it's nice and clean and just as smooth as you can see. I have done it to both, and it doesn't have to be perfect. Just make it flat and smooth so that you can fit the servo part into the wheel. So now you have to take this plus of the servos and just cut about between the 2nd and 3rd hole. Watch out, because when you cut it, it's gonna shoot everywhere, and I'm in the garage right now, so I don't really care. So I've already done the 2 servo motors, and if it's too big, just trim it down little by little, and it should fit just about perfect with the wheel. So as you can see, I have my hot glue gun ready, and just apply some hot glue onto the servo and just glue it down firmly and just press it onto the servo. So now I'll be showing you how to center the servos. So first, the code says servo.attach11, which means that the pin number is 11, so I'll connect the white wire to pin 11. And as I told you, the red stands for 5 volt and black is for ground. And now just upload. Takes a while. So now I've input the center servo code, and as you can see, my servo is spinning right, and that's not correct. So if your servo is moving, then you're gonna have to use a Phillips screwdriver, and you can see a hole right there, and just turn it slowly until it stops. And if your servo does not move when you insert the code, that means your servo is already centered. So now I centered this servo, and I'm going to center the next servo. And so now that I have centered both servos, it's time to attach them to the kit. So basically what you want is to have the part, the opposite end of the turning joint, to face back. And it's going to stick out a little, but that doesn't really matter. So do the same for both. And just take the track, put it on, and what you're gonna do is trying to find where you want to attach the servo. To just stretch it really tight. The tighter, the better the track performance will be. And I see that my servo should be about here. And what I'm going to do is apply some hot glue on the bottom. And I'm just going to let it rest right here. Just hold it down for a few seconds and it should dry. And you're just gonna do the same for the other side. Just line it up with the other servo. And now you're done. Now we're gonna move on to our ping sensor. So we're gonna have to test to make sure it works. So what you're gonna do is take 3 strips of jumper wire connectors and just connect them to the pins sticking out onto the sensor. And then you're gonna take 3 other jumper wires and just connect them to the other end of the jumper wire connector. Now just connect the pin sensor to the Arduino, and you can find the code in the file example sensor ping, or you can just click the link in the description. So ground 5V, and you see that the pin is 7, so just connect it to pin 7. And it's always good to verify your code just in case something's wrong. And after you verify, just upload if there isn't any problem. So your ping sensor should start to blink, and after you upload the code, press Tools, Serial Monitor, and you should see a windows that pop up. Like this. And if you have numbers just come in, it will show the distance that the ping is from with an object in front of it. So you can just play around with it, put your hand in front, and the distance should vary. So now that you're done testing your ping sensor, it's time to put on the standard servo. Now the standard servo only rotates 180 degrees unlike the continuous motors, which can turn 360 all around. And when you look at the circle, it should say a number 1 on one of the sides. And it is important that you point 1 straight and glue the sensor on like that, is because if you don't put it like that, then the sensor will only turn from left to center or right to center or something like that. So if you put the sensor straight like that, then your sensor will operate properly and just spin like that. So what I'm gonna do is I'm just gonna take it, apply some glue on the bottom, and just glue it down right in the center. So now you can find something like styrofoam or cardboard or something like that. Just glue it on, attach the sensor, and so for the head, I just found 2 random blocks of styrofoam, and I'm just gonna glue it on top of each other. And what I'm gonna do is take 2 pins, because you don't want to glue the sensor and just damage the bottom parts. So what I'm gonna do is just basically take some pins, attach the sensor like that, and just place the pins in the 2 holes. Two holes here and here. So just to save time, what I did was I just found some random nails lying around the garage, and I'm just gonna stick it into the hole and just place it like that. And I'm just gonna do the same for the other hole. It doesn't look perfect, but it will still do the job. So now, all you have to do is just apply some glue onto the standard servo, and just place the head right there. Now, most of your hardware is about complete, and now it's time to wire everything together. Now for the wiring, it gets kind of complicated and confusing. So basically, your robot will have to share a common ground, and it will have to share the same power output, because Arduino only has one 5V slot. So what I'm gonna do is I am going to take some jumper wires and just plug them 1 to 5V and just plug it into one column on the breadboard. Now what you're going to do is take the 5V slots on the sensor and servos and connect them to the same column. Now after you're done, you're going to do the same thing with the ground. There is 2 grounds, but however, all of them will have to share one ground in order for this to work. Just connect the wire to the ground pin and just connect it to one column and just connect all of the servo and sensors into the column. And remember, ground is usually black on the servo wires, so that will help you from confusement. Confusement, is that even a word? So now I am done with both the ground and the 5V. However, each of the sensor and servo will need to receive command signals. So that's going to come in from the signal pin, and each of them will have an individual pin on the Arduino. So now on the code it says the pins that the servos and sensor will need to be plugged into. So for the ping sensor, it would be pin 7. For that's interesting. Okay, so for the left servo, you need to connect it to pin 9, and for the right servo, you will need to connect it to pin 10. And lastly, for the standard servo, just connect it to pin 6. And now you're done with the wiring. You can just upload the code I have provided for you in the description. So after you have inputted the code, you will notice that the robot will be going backwards. And to fix that, all you have to do is switch the pin numbers of the left and right servo. And it should be going forward. Now, you don't want the robot to always get their power from the computer, so that's where the battery pack comes in. You will see that there is another circle outlet on the Arduino, and just connect the battery pack and it will have its own independent power supply. Thanks for watching, guys, and I hope you like, comment, and subscribe.